Hi, my name is Raffl from the Technical University of Munich, and in this video I will briefly present you our paper entitled Extending Geodetic Networks for Geo-monitoring by Supervised Point Cloud Matching. In this work we tackle a key challenge in deformation monitoring, bringing dense 3D point clouds together with the accuracy and reliability of geodetic networks. Let me start with the motivation. This image shows the summit of Mount Vogel in the Alps. The southern part is slowly detached and threatens to collapse. Movements are only a few millimeters per month, yet the consequences of failure can be severe. In such environments, we need early detection, but we also need statistical reliability. In geodetic monitoring, we traditionally distinguish between two approaches. Network-based approaches provide redundancy and rigorous significance testing, but they are spatially limited and rely on marked points. Point cloud-based approaches, on the other hand, offer high spatial resolution and access to high-risk areas, but they lack identical points across epochs, and therefore they also lack strict statistical control. This leads to our central research question: how can we combine the spatial richness of point clouds with the statistical strength of geodetic network adjustment? This question leads directly to our main contribution. First, we propose a hybrid monitoring concept in which selected laser scan patches are transformed into virtual geodetic target points. Second, we introduce supervised ICP validation based on a Monte Carlo simulation to ensure that only geometrically reliable patches are used. And third, we integrate the resulting virtual targets into a free network adjustment, which enables rigorous statistical significance testing. Let me briefly explain how this works in practice. We select small scan patches. For each patch, ICP matching is performed. However, not every surface is suitable for ICP. Therefore, we introduce a supervised Monte Carlo-based validation. And finally, the validated virtual targets are converted into pseudo-observations and integrated into a free network adjustment, enabling full error propagation and statistical deformation testing. We applied the method to Mount Vogel, and it was possible to extend our existing monitoring network by many virtual targets with millimeter level accuracy. If you would like to learn more about these results and the method in general, I warmly invite you to read our paper, which is also open access. That's all from my side. Thanks for listening.